This section of the class is all about getting used to using this table. This table is absolutely uploaded to Canvas. If you have a printer available, I highly recommend that you print it out and have it in front of you. It's okay to try and use a digital version and look at it on your computer, but I promise you it'll be much easier if you have a physical paper copy. So basically what this table does is it tells us the probabilities for all standard normal random variables that have mean 0 and standard deviation 1. That might seem like a very narrow set of uses for this table. I assure you the table does not have a narrow set of uses. Basically, in subsequent lessons, we're going to learn how to take any normal distribution ever and make it fit this table. So for today's lesson, the goal is let's understand how to read this table, find probabilities from it. But over time, we're going to be able to relate this table to everything that we do moving forward in the course. So the way the table is organized, there's two sides. The side that has the graph at the top is the negative value side. The side without the graph is the positive value side. On either side, the first two digits, like this negative 2.5, occur in the far left-hand column. The third digit, like this 0.005, chooses which column to line that up with, the row that you've already chosen. Once you've correctly lined up a column and a row, what the probability tells you is what's to the left of that z value. To the left of is the same thing as less than. So essentially, we've got a standard normal that looks like this. If you tell me z equals negative 2.55, I know that somewhere around here, since everything's centered at the mean of 0, so if this is negative 2.55, what the negative 2.55 entry in the table does is it accumulates all the area negative 2.55 into the left. So in order to find this table entry, I'm going to start with the first two digits, negative 2.5. On the negative side of the table, I'm going to go down until I hit negative 2.5 in the first column. That tells me what row I'm in. I'm then going to look at the third digit, in this case 0.05. That tells me what column to go over to. When I line up this 0.05 column with this negative 2.5 row, that's where I find the value 0.0054. So basically these first four questions where they're asking me z is less than, they're asking me exactly how the table is organized. So my only goal is find this entry in the table, report what the probability is. For the second question, 0.87, I need to be on the positive side of my table. On the positive side, I look for 0.8, then I line that up with the column marked 0.07. When I line those two up, I find the probability 0.8078. For number 3, it says that the z-score we're looking for is 1.04. So on the positive side, I go to 1.0 as my row. I move over to the 0.04 column, and it lines up as a probability of 0.8508. For z is less than negative 0.34, I'm on the negative side, negative 0.3, go over to the column marked 0.04, and I get a probability of 0.3669. So again, each of these first four questions, since they're less than questions, just asked me to find the exact table value. I've done that and recorded the first four answers. Questions 5, 6, 7, and 8 look exactly the same as the questions above. The only difference is I now have a greater than sign instead of a less than sign. The entire area under the curve represents all the probabilities of everything that can happen. We know that probabilities are strictly bounded by 0 and 1, so when I say all the probabilities, everything under the curve represents 100% of the probabilities, or as a decimal, 1. Since we found the shaded area to the left of negative 2.55 to be 0.0054, if we want to find the area to the right of it, that's really all this unshaded area. It's also the complement of 0.0054, meaning if we took 0.0054 and add it to this unshaded area, we should get 1 or everything that can happen. So the way that we're going to solve for greater than questions is we're just going to take the table probability and do 1 minus that probability. So if I do 1 minus 0.0054, that's going to give me 0.9946, which is the correct answer to z is greater than negative 2.55. If I do the same thing with the table entry for 0.87, 1 minus 0.8078 is going to give me 0.1922. If I do it for 1 minus 0.8508, that's going to give me 0.1492. And if I do it for 1 minus 0.3669, that's going to give me 0.6331. So again, less than, I'm just looking it up in the table. Greater than, I'm taking what I looked up in the table and doing 1 minus that value. Last way we're going to have to understand the table is finding between numbers. So what between's really asking me to do is graphically, here was negative 2.55, here was 0.087. We know from 0.087 back to the end of the earth has probability 0.8078. We know from negative 2.55 to the end of the earth has probability 0.0054. We want this shaded area in between. So what that shaded area really represents is this whole distance from the larger p-value minus this distance, which is going to be unshaded. So really, whenever we do a between question, we find the two table values. We take the larger table value minus the smaller table value. So the table value for 0.87 was 0.8078. We're going to subtract from that the table value for negative 2.55, 0.0054. When I put that into my calculator, 0.8078 minus 0.0054, I get 0.8024, which is the correct probability between z being between 0.87 and negative 2.55. If I do the same thing in problem 10, 1.04 had probability 0.8508 minus negative 0.34 had probability 0.3669. Again, I'm going to let my calculator do this work. 0.8508 minus 0.3669. I get that to be 0.483